Alright, we're going to talk about solving rational inequalities. It's going to be kind of similar to what we did with solving rational equations the other day. And it also is going to combine with what we did when we solved quadratic inequalities using a number line to figure and using some test points. So let's go ahead and take a look. So here's your steps. So the first step is to rewrite your inequality as an equation. Solve the equation like we did last class. Then we're going to use the solutions and any rejected values that would be causing it to be undefined to create test intervals on a number line. And then we'll test the intervals, test our endpoints, and write an answer in interval notation. Alright, so we're going to go ahead and take this and rewrite it as an equation. Okay, we're going to go ahead and solve this. Now we can either solve this by timesing both sides by x minus 5, or if you want to try to cross multiply, that works too. It's the same thing, but I'm just going to multiply by x minus 5 to both sides. Okay, so x minus 5 is over here canceled, so we're left with 2x minus 7. Make sure we distribute, so we have 3x minus 15. Okay, move the 2x over, so we have negative 7 equals 1x minus 15. Add 15 to both sides, so we have x equals 8. We also know that x cannot equal 5 because that would make the denominator equal to 0. So when we go to make our number line, we're going to put on 5, and we're also going to put 8. Okay, so now we're just going to test these intervals. So for the first one, let's test a number that's left of 5. I'm just going to use 0, a little bit easier to work with. So I'm going to plug 0 back in up top. So we have 2 times 0 minus 7 over 0 minus 5. And is that less than or equal to 3? Well, that ends up being 7/5, which is just 1 and 2/5. So we know that is less than. So this is going to be a smiley face. That one works out. All right, let's try one between 5 and 8. I don't know, let's try 6. Okay, so when we do that, we get 2 times 6 minus 7 over 6 minus 5, which reduces to 5 over 1. And is that less than or equal to 3? It is not, so 6 is not going to work. Okay. Now let's try another one. Let's go, I'm just going to use 9. When we plug 9 in, we get 2 times 9 minus 7 over 9 minus 5. And see if that's less than or equal to 3. Let's go ahead and simplify that left side, which is 11/4. 11/4 is 2 and 3/4, which is less than 3, so we know that would work as well. So now I need to go ahead and rewrite this as an interval notation. Okay, so I'm going to go ahead and say that x is going to be, it works out when x is going to be to the left of 5, so that's going to be negative infinity to 5. And it goes to 5, but you have to be careful because remember, we know that x can't equal 5. So sometimes it's kind of helpful when I write these points, I'll put an open dot to know that it won't equal 5, but I know that it actually does equal 8. So that sometimes helps me here. So since it's negative infinity to 5, but it can't include 5 since we learned that up front, that would be a parenthesis, and then we have our union, and then it's going to include 8 since 8 is actually a solution and it's less than or equal to, okay, and then that's going to go to positive infinity. Alright guys, let's take a look at this example. I'm going to go ahead and rewrite it so that it's equal to 1. You don't always have to do that, but if it helps you to do that, go for it. Remember, we're going to multiply everything by what the common denominator would be. So this would be x minus 1, x plus 1, x minus 1, x plus 1, and then at the bottom as well, x minus 1, or at the right side, x minus 1, x plus 1. Okay. So now our x minus 1's cancel, so we're left with 5x plus 5. When we distribute, then we're left with, now be careful here, oh, our x plus 1's cancel. So now be careful here, we're going to have negative 2x squared plus 2x, since this is technically a negative 2x, okay, equal to, well, this is just x squared minus 1 if I multiply it out. Now let's go ahead and combine like terms. So we have negative 2x squared plus 7x equals x squared minus 1. You could move the x squared and the minus 1 over to the left-hand side, But if you do that, then you would have to make sure we factor out a negative when we go to solve this quadratic. I'm just going to go ahead and add 2x squared to both sides, subtract 7x, and subtract 5, and get everything over to the right side. So I have 0 equals 3x squared minus 7x minus 6. Now when I go to factor this, well, multiplies the negative 18 but adds up to 7. That'd be 3x and x. Okay. Remember, it's going to be negative 9, positive 2. So this will be plus 2, and 3 goes into 9 3 times. Okay. So we're going to have x equals negative 2/3 and also 3. Okay. So when I go to make my number line, I have negative 2/3. I have 3. But also we make sure that you add or put on there the values that would make our original equation undefined, which would have been x equals 1 and x equals negative 1. So what's also kind of helpful sometimes for us so that we know like what points are included or not is when we go through and we say, okay, well, our points that can't actually work, which were negative 1 and 1, I kind of sometimes will put an open dot there so that I remember that it actually won't include those points. Also, I know for 2 and negative 2/3 and 3, since it's just less than, I know that it's not going to include those points since it's not equal to. So sometimes I'll put that open dot so that'll help me when I actually do this next part when I write my answer in interval notation. So now what I'm going to do is I'm going to pick test points. So like for the first, I'm going to start on the right side. So if I pick 4, I'm going to do 5 over 4 minus 1 minus 2x, or 2 times 4 over 4 plus 1, and see if that's less than 1. I'm just going to plug that right into the calculator, and when I do get a number that's less than 1, so that actually ends up working out. Okay. Now I'll pick a point that's between 1 and 3, which I'll try 2. Hey, I plugged that into the calculator. It actually is not less than 1, so that does not work. Okay, I pick 0. That ends up being negative 5 is less than 1, which is true. And then this one, you have to just pick a point between negative 1 and negative 2/3. You could pick like a fraction like negative 3/4, or since we're just doing a test point, we can use even a decimal. So I think I did negative 0.7, and when I did that, I ended up getting like 1.2 or 1.7 something. So that ended up not being less than 1. And then this last, I picked negative 3 or negative 2. Any point like that will work. And it ends up actually being less than 1 once I plug that into the calculator. So now when I actually go to this last part to write my interval notation, that's where these open dots sometimes help us out, because we're going to go from negative infinity to negative 1. And then it's going to go from, start at my next section that actually worked was negative 2/3 to 1. So negative 2/3 to 1. And then my last section was 3 to positive infinity. All right, that's our final answer.